Here we have our first example that says find the vertices and foci of each ellipse. Graph each equation by hand. Alright, so we're given an equation here that says x squared plus y squared equals 18. Now this does not look like our normal standard form of an ellipse does that I gave you in the last video. So we need to get it into the proper form. Now both of the standard forms for the ellipses always are equal to 1 on this side. So that's our most important thing. In order to make this equal to 1, we're going to divide everything by 18. Alright, now by doing that, we have a new equation here that says x squared over 18 plus, here the 9 will cancel into the 18, so we'll have y squared over 2 equals 1. Now this looks much better as a proper standard form equation. And I'm going to give you another little hint, a little trick that I always do, and I think that it makes all the difference in the world. I like to write out a squared, b squared, c squared, a, b, and c. If you'll remember from the last video, we talked about the relationships and what A was, what B was, and what C was. So if you can have a place to have all of these things listed out, you won't lose track of your information. Alright, now looking at this, one of these numbers has to be A squared and the other one has to be B squared. In this case, the largest one is 18. So that tells us that 18 is A squared and B squared is 2. We also have a relationship between A squared, B squared, and C squared, and that is A squared minus B squared equals C squared. So that means that 18 minus 2 has to equal C squared, or C squared is 16. So now I can go ahead and write that in. I know now what all of my values are, and I can just take the square root of those to find the A, the B, and the C. So A will be the square root of 18, and the square root of 18 in better terms is going to be 3 square roots of 2. Now if you don't remember how to do that really quickly, if you were taking the square root of 18, since it's not a perfect square, we would have to think of two things that multiplied together to get 18. So say like 9 times 2. We want one of them to be a perfect square. So instead of saying the square root of 18, I can call it the square root of 9 times the square root of 2. And the square root of 9 is 3. And we can't do anything with the square root of 2. So this is the simplified version. Now, another thing that I like to make note of at this point is which part it came from. So this was underneath the x's. I just like to make a little note of that as I go. The b is going to be the square root of b squared, so it would be the square root of 2. And remember that we got from underneath the y's. And then c is going to be the square root of 16, which in this case is 4. And again, a and c are always on the same axes. Okay, listing out this A, B, and C is probably the most crucial part of being able to solve and find all your parts of your ellipses. We'll pick this up in the next video and finish it out.